Let's try these. These are complex fractions. Remember I said before that we don't really want to have a three-story fraction. Three-story fractions are kind of a no-no. And over here we have some four-story fractions. That's even worse. So you notice that this heavy fraction bar there, that one, that's our division problem. So we're going to write this as a division problem. Then we can solve it. Don't try to just plug this into your calculator because the calculator will not understand if you just type in 2 over 3 over 3. Your calculator will not calculate that correctly. You have to tell the calculator exactly what you're doing because they don't understand three-story fractions either. So this is 2/3 divided by 3. Okay, now we're going to make this 3 because we're dividing a fraction into a fraction. So now when we're divided by a fraction, you have to remember to multiply by the reciprocal. So now it's 2/3 times 1/3. Remember the first fraction did not change. We're multiplying by the reciprocal of the fraction that we were dividing by. And then we could just multiply straight across. 2 times 1 is 2. 3 times 3 is 9. 2 9s. When you have a division problem between two fractions, it looks like a four-story fraction. That's a division sign. Write it as a division problem. 4/5 divided by 8/15. Then use your process for dividing fractions is to multiply by the reciprocal. Turn it into multiply by the reciprocal times 15 over 8. Seriously, it's easier that way. Keep the first fraction the same. Reduce this one. 5 goes into there once. 5 goes into there 3 times. 4 goes into there once. 4 goes into there twice. 1 times 3 is 3. 1 times 2 is 2. It's 3 over 2. It's okay to leave your answer as an improper fraction as long as it's reduced. All right, now we have variables. Let's do the same thing. So now we have x over 5 divided by y over 3. So this x over 5 stays the same. Multiplied by the reciprocal, 3 over y. Nothing reduces. We just multiply straight across. X times 3 is 3x. 5 times y is 5y. 3x over 5y. And then the last one, we're going to change this mixed number into an improper fraction. So if you want to use that little shortcut rule, 4 times 6 is 24 plus 3. Disregard the negative sign, and we're going to throw the negative sign on the end. So this is the negative of 6 3/4. Just do 6 3/4. 4 times 6 is 24. That's 27 fourths. Then put the negative sign back on it. Okay? Because otherwise, then you can't make part of the mixed number negative and the other part positive. You can't do that. If it's negative 6 3/4, it's negative 6 and negative 3/4. Okay, so now we have 3/8 divided by negative 27/4. So now I can multiply by the reciprocal. 3/8 times negative 4/27. And now in this one I can reduce because 3 goes into there once and it's good. 3 goes in there 9 times. We can reduce the 4 and the 8, but don't just lose your negative sign. 4 goes into there once. 4 goes into there twice. So we have a negative sign. So it's negative because a negative divided into a positive would be negative. And we have on the top 1 times 1, which is 1. 2 times 9 is 18. 1/18. Okay, check to see how you did. And let's go on. Now these complex fractions have math problems in the numerator or the denominator or both. So in that case, you have to do the math and then do the math again. Okay, well, some of them are not that hard. Like on A, 19 minus 4 is 15. This is just 15 over 6. That's not reduced. We have to reduce now. Reduce the 15 and 6 with a common factor of 3. So that's going to be 5 over 2. 24 minus 15 in the denominator. See, the 48 is going to stay the same for now. 24 minus 15, I believe, is 9. And then reduce that one. Those are both divisible by 3, I believe. So that would be 16 over 3. Perfectly okay to leave an improper fraction answer. Now on C, we have 2 math problems and then a third math problem. The first math problem is the numerator. So I'm going to go down here and I'm going to add 4/5 plus 3/4. I need a common denominator, so I'm going to multiply this by 4 over 4 and this by 5 over 5. So that's going to be 16 over 20 plus 15 over 20. So that's 31 over 20. So my numerator is 31 over 20. Okay, now I have to do a second math problem in the denominator. So that math problem is going to be, let's see, 4/5 minus 1/2. With the common denominator, I'm going to multiply that one by 2s, this one by 5s. So it's going to be 8 over 10 minus 5 over 10. That's going to be 3 over 10 over 3 over 10. Okay, now I have a complex fraction that I can divide. So I have 31 over 20 divided by 3 over 10, which means I'm going to have 31 over 20 times 10 over 3. And then I'm going to reduce the 10 and the 20 and multiply straight across. 31 over 6. Okay. Well, that was a lot of stuff. So if you have a complex fraction, which means a fraction problem over another fraction problem, then you have 3 problems to do. You have the math problem in the numerator, the math problem in the denominator, and then the math problem of the numerator over the denominator. All right, let's try problem D. In the numerator, we have 3 squared plus 4 squared. All right, well, let's do the math. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. Over negative 135 over 9. So I'm going to write this as a division problem. 25 divided by negative 135 over 9, which is now 25 times the reciprocal, still negative, 9 over 135. Now I could multiply 25 times 9. This 25 is over 1. But I'm pretty sure I can reduce the 25 and the 135. The reason I know that is because 25 and 135 both end in a 5, so they're divisible by 5. So I'm going to divide this by 5. 25 divided by 5 is 5. And I'm going to divide this by 5. Let's see, 5 into 135. Should go in there 27. Aha, I just noticed something now. Here's what I have. So far, I'm not going to multiply yet. I have 5 over 1 times negative 9 over 27. I did not notice this before, but this negative 9 over 27 is reducible. I could multiply across now, but then it won't be reduced. I'm going to reduce this first. So 5 over 1 times, I'm going to divide both those by 9. Negative 1 over 3, because 27 divided by 9 is 3. And that's going to be negative 5/3. Nice. So there's lots of things you can do to help the math go along a little quicker. And when multiplying, not when dividing, when multiplying, just like this one and that one, you can reduce first so that you don't have to reduce so much later. Okay, more. Now these are a little bit more complex. So on these, same thing. We have a math problem in the numerator. Then we have a math problem in the denominator. Then we have the numerator over the denominator. So the first math problem we have to do is 1 minus 3/4. Well, 1 is 4/4. So 4/4 minus 3/4 is 1/4. So that's 1/4 over the denominator. All right. Now, when I do 1/8 plus 2, I'm not going to write 2 and 1/8. Okay? If you do write 2 and 1/8, then use what you know to make that into an improper fraction. 2 times 8, 16, plus 1, 17, 17 eighths. Or you could make this 2 into 2 over 1, get a common denominator, multiply by 8 over 8. So that's 16 over 8 plus 1 over 8 is 17 over 8. 17 over 8. Okay, then turn that division into multiplying by the reciprocal. 1/4 divided by 17 over 8 is the same as 1/4 times 8 over 17. And then reduce, if possible, after its multiplication. Not in the division phase. After its multiplication. 4 goes into 8 2 times 2/17. Yay, okay, all the rest of these problems have just variables. Okay, so, same thing. Now this numerator here, there is nothing we can do with that. It's a single fraction. It's a plus b over 2. We're just going to leave it a plus b over 2. Now, see, this is two fractions. These I need to combine together. If it's a single fraction, that's good. I can use a single fraction in multiplication and division. But I can't use two fractions in multiplication and division. So in the denominator, we have 1 over a plus 1 over b. It's addition, so we need a common denominator. So we're going to multiply this one by b on the top and the bottom. Don't forget it's the top. And multiply this one by a. So now this becomes b over ab. This one becomes a over ab. So when we add them together, a plus b, because I like alphabetical order, over ab. See, now it's a single fraction. So that's my denominator. So here's what I have now. I changed, let's go back to this. A plus b over 2 divided by a plus b over ab. Okay? All right. Now I know some of you are tempted to do two things at once, such as immediately write that as multiplying by the reciprocal. But I just want to keep things simple. So now I have a plus b over 2 times the reciprocal, ab over a plus b. Okay, reduce. And you might be looking at that going, reduce? Yes. See, this whole numerator is a plus b. This whole denominator is a plus b. They are the same. It's like canceling out a 5 and a 5, or a 3 and a 3. Canceling out the a plus b with the a plus b. And remember, when you cancel those out, they turn into 1s. So it's 1 times ab, which is ab. And 2 times 1, which is 2. Our final answer on that one is ab over 2. Okay. All right, let's try C. This would be a good one now that you have some experience. You try it. And D, pause, try it, unpause, check your answer. Okay? Numerator 1 plus 5, or 1 over 5, sorry, plus 1 over x. common denominator, multiply by x, multiply by 5. So now I have x over 5x plus 5 over 5x, which is x plus 5 over 5x. So that's my numerator. Okay? X plus 5 over 5x. All right. See, I'm trying to keep things straight. Don't write stuff all over the place and then forget where it goes. All right, the denominator. Look, this is already a single fraction. See, it has a single denominator. It's already a single fraction. So I don't have to do anything with that except now write that into my problem and divide. Okay, so that division problem is x plus 5 over 5x divided by, I know I'm writing as division first, x plus 5 over 2. That way I can keep it upright. All right, so then I'm going to turn that into multiplied by the reciprocal. Still x plus 5 over 5x times 2 over x plus 5. What happens? The x plus 5s cancel each other out. Final answer? 2 over 5x. Nice. Okay. So I hope it's going well. This is the last problem to do. This is kind of a fun one. In our numerator, we have a math problem to do. See, that's two separate fractions. Yes, that 1 is a fraction. So that's 1 over 1 minus 1 over x. Okay. Common denominator because we're subtracting fractions. So we'll multiply this by x. Now you could multiply this one by 1, but what does that change? Oh yeah, nothing, because 1 is the identity for multiplication. So now we have x over x. Leave it x over x. Don't say, oh, but that's 1. No, we knew that it was 1. That's where we came from. Minus 1 over x. See, we had to do that to get a common denominator. So that is now x minus 1 over x. So this numerator here is x minus 1 over x. Okay, so now we need the denominator. The denominator, we have addition. Looks almost the same, but it's addition. So it's 1 over 1 plus 1 over x. So let's multiply this one by x. And when we do, then we're going to have x over x plus 1 over x. Okay, and that's x plus 1 over x. So this becomes x plus 1 over x. Okay, so now our division problem is x minus 1 over x divided by, yes, I'm writing as division first still, x plus 1 over x, which is now going to be the multiplication problem, x minus 1 over x, times the reciprocal, x over x plus 1, and this x in the denominator cancels out with this x in the numerator, leaving us with x minus 1 over x plus 1. Okay, now, see, I'm putting a box around that. That's my final answer. Do not cancel out those x's. Here's why. See, let's just pretend that we know what that x number is. Let's say that it's, I don't know, 4. If x is 4, then this is 4 minus 1 over 4 plus 1. If I cancel out these 4's now, then I get negative 1 over positive 1, which is just negative 1. But, see, this fraction bar here is almost like parentheses. So it really wants you to do the numerator and denominator separately and then divide. So that 4 minus 1 is 3, and that 4 plus 1 is 5, and 3 over 5 is not equal to negative 1. See, you can't cancel those 4s. Same way, you cannot cancel these x's. That's it. It's x minus 1 over x plus 1. Do not cancel those x's, because it's adding or subtracting. Now, if it was x times negative 1 and x times 1, yeah, then we could cancel them out. But it's not. It's x minus 1 and x plus 1. Okay? So there we go. Well, I hope that wasn't too long. There was a lot of fraction work here on the last couple of pages with those complex fractions. I hope you got all the way to that. So good luck with that.